This is our last video for the exam review. It's Unit 7, which is solving quadratics. This is our most previous unit that we have done in class, so there's a little bit fewer questions on the exam review than for the other units, but that's because it should be most fresh in your head. Number 1 should be very simple. It says, use the graph to answer the questions. What are the roots? Well, remember, roots are the same thing as x-intercepts, or solutions. And here, I have two x-intercepts. It looks like one of them is at -2, and the other root is at 6. Now, those are two rational x-intercepts. So, because those roots are rational, yes, this quadratic could be factorable. Whatever the equation of the quadratic for that graph is, we would be able to factor it. Now, because it's factorable, and because I know the roots, we're actually going to write the equation for this quadratic. And here's how you do this. If you remember, we did a couple of these. If I know that the root is -2 and +6, I am able to write the factored form for this quadratic because I know those roots. Well, remember, whenever I have this zero product law, if I have factored form like x plus 3, x minus 1, you would set each factor equal to 0 and solve. So you ended up getting a solution, and we always notice that the sign of the solution was the opposite of the sign in the factor. So if I know the solution is -2, that means the factor that gives that to me is +2 and -6. So those are the factors. In order to find the standard form like they want, you need to distribute. So x times x is x squared minus 6x plus 2x minus 12. And simplifying here, the like terms just combine. So you have x squared minus 4x minus 12. If you're not sure if that's correct or not, use your calculator. Type that equation into the y equals of your calculator and hit graph. You should notice that you cross at -2 and 6, so that looks like the graph that you were given on paper. All right, so number 2 here. Let's solve by factoring. 2, 3, and 4. Remember, when you solve any quadratic, you need to start so that it is set equal to 0. So here you need to subtract 24x from both sides to start so that you get 0 on the right. This would be 6x squared minus 24x equals 0. To factor this, I have two terms. What I always start with when I factor is looking for a GCF, a greatest common factor. Here it looks like I have a GCF of 6x. So I factor that GCF out, and I'm left with x minus 4. Once I know factored form, that's as far as I can go, I set every factor that has an x equal to 0. So I set 6x equal to 0 and x minus 4 equal to 0. Well, when I have 6x equal to 0 and I divide by 6, that means one of the solutions is 0. And this guy here, I add 4 to both sides, and I get that the other solution is 4. So 0 and 4 there. Number 3 has to start off the same way. I have to subtract the 8 from the right-hand side. I cannot factor this until I have the quadratic set equal to 0. So I look for a GCF, 3, 2, -8, not a GCF for those 3 values. So I'm going to do a method of split the middle here. I have 3 terms. So I need to find 2 numbers that multiply to -24 and add to the middle number of 2. So if I write out my factors for 24, I'd have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Some that will give me a add to 2 would be -4 and +6. Okay, -4 times 6 would be -24, and those add to 2. So what you have to do is you now need to split the middle. That means that the first and the last term come down. They don't change. But the middle term gets split up into the 2 values we just chose. And what we do is you group. So you put the first 2 in a group and the last 2. and you look for a GCF for both groups there. The first group, you can pull out an x, so you have 3x minus 4. The second group, you can pull out a positive 2, and you're again left with 3x minus 4. That's a good thing because your factored form here, these are the same, so you have x plus 2 times 3x minus 4. And now that you're factored, you can set both of those factors equal to 0. All right, when you do that, you'll subtract 2 from both sides, so you'll get a solution of negative 2. And here you would start by adding 4. So you have 3x equals 4, divide by 3, and the other solution is at 4/3. So that's reviewing of split the middle, which we did back in Unit 1 on the review, and also solving by factoring. Number 4 should be a little faster than the last one. You do have a trinomial. There is no GCF, but because the leading coefficient here is 1, you can skip right to the factored form. All you need to do is find two numbers that multiply to negative 48, I'll write it down here, and add to negative 2. Well, you'd have 1 and 48, 2 and 24. It turns out that the numbers you're going to use are going to be 6 and negative 8. So when I pick those two numbers, I can immediately put those right into my factored form. There's a shortcut. Now, yes, you could go through the entire split the middle method if you'd like, but if you can get here faster, you'll save a lot of time. So now you set both factors equal to 0. Right? X plus 6 equals 0 gives you a factor of negative 6. I'm sorry, a solution, not a factor. And another solution of positive 8. So that was a little bit faster than the previous problem. Okay, so hopefully you're good at factoring. If you are still struggling with factoring, go back to Unit 1 on your review. Try those factoring problems again, or ask your teacher. We can give you some extra factoring problems as well. 5 and 6 ask you to solve by graphing. So you need a graphing calculator here. What we want you to do is just type that equation into your calculator. Oops. So the first one is 2x squared plus 9x minus 35. You're going to graph that. And you don't need to see the bottom. You could change your window so you can see the vertex. But here, I can see both x-intercepts. So all I'm going to do is trace this quadratic. I'm going to hit second trace. And the option I choose is number 2, 0. Remember, zeros are the same thing as roots or x-intercepts. You only use your left and right arrow keys here. So I'm going to slowly go, I'm hitting to the left here. I'm still at negative 3. I'm working over so I can see it. We're getting closer because we want to find our left bound. Here's my cursor. The left bound here means that you need to be a little bit above the x-axis. That would be to the left of that x-intercept. You hit enter for the first time. Now you should be able to use the right arrow key to get to the other side of the x-axis. I'll hit enter a second time and enter a third time. And it tells me that one of my x-intercepts is at negative 7. Well, that's good. That's a nice rational number. Let's trace the other x-intercept to make sure that that works out as nicely. So second trace again, number 2. And you're going to take your cursor and you're going to go back the other way. So you have to get back over so you can see your cursor on the other side. It's getting there. We're at negative 1. All right, now we're in positives. Here we go. Now this time being on the left of this x-intercept means we're going to be a little bit below the axis. So that's our first enter. Arrow to the right, only the right key so that you get to the other side of the x-intercept. Hit enter your second time, guess for your third time. And that root's at 2.5. Those are both rational roots. So we don't ask this question, but just so you remember, yes, this quadratic could be factored because those are both rational roots. Okay. Let's do the same thing in number 6. We're going to start by graphing the quadratic. So we'll clear out what we have, and we have negative x squared this time, minus 2x minus 48. Oh, no, I was looking at the wrong one. I'm sorry. Negative x squared plus 4x plus 10. Okay, so when I hit graph, there's my parabola, and I want to trace the roots just like I did the last time. So second trace, number 2. My cursor here. If I want it to be the left, when my parabola is upside down, when I want it on the left, this time the left is going to be a little bit below this x-intercept. You'll hit enter, because you should still be able to arrow to the right and get to the other side of the x-axis like I have here. Enter a second time and a third time, and I get a root at negative 1.742. That is definitely not rational, right? At least not that I can tell. So we'll do the same thing. Second trace, let's find the other root. We're going to arrow to the other side. So we're still trying to find our left bound first. Just takes a second to, there we go, I can see it now. So this time our left bound is going to be a little bit above the axis. Hit enter. Arrow to the right so that you can get below the axis. Hit enter again, and a third time, and your root is at 5.742. Again, it doesn't ask you this question, but those are two irrational numbers, so this is not a factorable quadratic. So just make sure you still know the difference between when something is able to be factored and not able to be factored. Number 3 has us using the quadratic formula. Right? So it says leave answers in simplest fraction or radical form. Some of us are still having trouble with this after our test. So if you're having trouble simplifying, make sure that you pay attention here so that you can understand how we want you to simplify these values. Number 7 is not set equal to 0. So in order to use the quadratic formula, you need to subtract 18 to the left-hand side. Now for the quadratic formula, you do not have to divide. You can, I know there is a GCF of 3 here, and you could divide every term by 3. You do not have to do that for the quadratic formula. That would only be complete the square, which we'll get to in a couple of minutes. For now, you just need to know that the A's value, because your quadratic formula is over here in this box, you need to know that A is 3, B is negative 3, and C is negative 18. For this guy, we'll come back to that later. So our quadratic formula is x equals. You start with the opposite of b. Here that would be positive 3 plus or minus. Now my square root, or under the square root, is that discriminant, which we're going to talk about on the bottom here. You take negative 3 in parentheses squared minus 4 times a times c. That whole thing, including the 3 plus or minus, goes over 2 times a. Now you want to simplify this. We're going to take 3 plus or minus. We need to know what's under the radical here. So you take your calculator, and you would do negative 3 squared in parentheses minus 4 times a times c. And you should get 225 underneath the square root. And that's all going to go over 6. Now, one thing here, I'm going to skip down to the discriminant part and then go back. That number under the radical, that square root of 225, or the 225, not even the square root, that is the discriminant. Now, you should know about that discriminant, and I'll show you here, 225 is a perfect square. So because this discriminant is a perfect square, that means that we're going to have 2 rational answers as our solutions to our quadratic formula here. So we need to simplify this. This becomes 3 plus or minus 15 over 6. Now here's the problem that some of us are having. You can't leave your answer like that. That is not simplest fraction form. In order to be simplified, you need to turn this into 2 fractions. You need to find the value of 3 plus 15 over 6 and 3 minus 15 over 6. You need to actually simplify those into 2 fractions. Well, 3 plus 15 is 18 over 6, which is 3. That's one rational root. And 3 minus 15 is negative 12 over 6, which is negative 2. So there I have two rational roots, just like the discriminant hinted that I would get. Okay, so now for the next one, I might have to erase some of this. But we'll see. We'll leave it, and then if I have to erase it, I will. I'll just be a little messy. I'm already set equal to 0. I'm still using the quadratic formula. So you still need to make sure that you know that A is the 4, B is -2, and C is 3. So when we put this into the quadratic formula, we have x equals, the opposite of our b here is +2, plus or minus 1 giant square root. The b goes in parentheses, -2 squared, minus 4 times a is 4 times c. Again, everything, including that 2, over 2 times 4. Now to simplify this, you need to figure out what goes under the radical. What is that discriminant? So you're going to take your calculator, and you'll do -2 in parentheses squared minus 4 times a times c. And you get -44 under the radical. Now just like the last problem, if I go way down here, the discriminant for this problem, -44, that tells us that there are going to be two imaginary roots. So I'm going to have I in my answer. I need to simplify this radical right here. Okay? I don't want to leave -44 under a radical. So you need to think about what perfect square goes into 44. That'd be 4. Remember, you're going to have an I. So you're going to have I, radical 4 times radical 11, which is 2I radical 11. That 2I radical 11, you're going to replace that square root with. So what you'll have, the first thing is just 2 plus or minus 2I radical 11 over 8. Now again, some of us had trouble with this on our test. You need to make sure that you simplify the fraction fully. We did simplify the radical. 2, 2, and 8 all have 2's that go into them. So you can divide 2 out of all of those coefficients. You get 1 plus or minus 1I radical 11 over 4. That is the most simplified form. And you can leave that fraction just like that. You don't have to split it up into 2 fractions or anything. You can leave it just like that. Those are 2 answers that are imaginary. All right, last one up in here, we're going to do completing the square. To complete the square, we are set equal to 0. Remember, complete the square has to have a leading coefficient of 1. You cannot do the complete the square process unless it's just a plain x squared. So the first thing we do here, since we start that way, is we're going to move the 23 to the other side. So I'm going to subtract 23 from both sides, and I get x squared minus 6x. Now when I move the 23, I put a box on both sides, equals -23 plus box. That is what I'm going to fill in by this process of complete the square. To fill in the box, you take half of this middle number and square it. Well, half of -6 is -3, and -3 squared is +9. You always put a positive in the boxes, because every time you square a number, it is positive. Now, the nice thing about this right-hand side, as we've always talked about, is that it's going to factor. Sorry, I got interrupted there. So I'm not sure where I was because I was really interrupted, but let's see. I think we were talking about the left-hand side of this, how that is a perfect square trinomial. And that trinomial is always going to factor really nicely. And it's going to factor as 2 factors that look exactly the same. And remember, the way it factors is always taking half of this middle term. So that'd be -3. So you have x minus 3 times x minus 3. But since those are the same, and I guess we can add here -23 plus, or 23 plus 9 is -14 on the right-hand side. Remember, you could skip this step right here, though, and remind yourself that those always condense. Since they are the same factor, we can write them as the quantity squared. Now, all we have to do is now take the square root. So I'd have x minus 3 equals, in front of my square root is plus or minus, Now, since I have a negative under the radical, I can simplify the square root of negative 14 to be I radical 14. And all you have to do now is add 3 to both sides. When you add 3, it goes in front of the plus or minus, which is 3 plus or minus I radical 14. And those are your two solutions. You don't have to do any more work other than that for this problem. Last problem on the exam. I have a set equal to 0. However, in order to finish complete the square here, you have to divide every term by 4, which would give you x squared plus 8x minus 1 equals 0. Now you are set up just like number 9, and you can finish the process of complete the square. You start by adding 1 to both sides, and you'll get x squared plus 8x, fill in your box here, equals 1 plus box. Alright, now to fill in the box, again, you take half of the middle number and square it. So half of 8 is 4, 4 squared is 16, and 16 goes in both boxes. The right-hand side is simple. That simplifies to 17. The left-hand side is going to condense. It's going to be factored into two factors that are the same. I'm going to skip right to the condensed form, which is x plus 4. Here it's plus 4 because this 8 is positive. All right, all I have to do now is take the square root of both sides. X plus 4 is plus or minus radical 17, and you subtract 4 from both sides. So your solution is negative 4 plus or minus radical 17. And those are your two answers, and that's it. If you need more help on any of those, ask your teacher for